a lot of people don't even know what food scientists do. Food science is the reason you can walk in a grocery store and have thousands of products available to you. The processing, the packaging, whatever.
Hundreds of thousands of researchers around the world are working to improve life and address imminent threats to humanity. Often their research ends up in the scientific valley of death in the form of publications and patents that never see the light of day. That is about to change. Welcome to the Lab to Startup podcast, hosted by Naresh Sunkara, founder and executive director of the Berkeley Postdoc Entrepreneurship Program at the University of California, Berkeley. This show has two main goals: share the stories of those who have successfully founded startups based on their own research, and highlight resources needed to help those aspiring to launch startups in the deep tech space. Whether it's electric cars, vaccines, addressing climate change concerns, or possibly establishing life on other planets, Naresh and his esteemed guests want to help scientists, engineers, faculty, and researchers bring their innovations to market. Learn more and subscribe today at labtostartup.com. And now, here's Naresh.
My guest today is Vickie Kloeris, a food scientist with an out-of-this-world career. She worked at NASA in space food systems for 34 years. She served as the NASA manager of the Shuttle first, and then the International Space Station food systems. She and her teams worked through the complex challenges of creating tasty, nutritious, long-lasting, easy-to-prepare meals that support the dietary and psychological needs of astronauts living on the space station. Vickie has worked with hundreds of astronauts to plan their favorite meals and holiday specialty meals for space travel. Vickie received NASA's highest honor, the NASA Distinguished Service Medal, in 2019, and so many other awards in recognition of her service there. In this episode of Lab to Startup, we talk about the history of feeding our astronauts, working with US military, evolution of food systems at NASA over a period of 40 years, depending on Russian Space Agency in the initial days, and also working with other space agencies around the world. Vickie shared the challenges for the future manned mission to Mars, and how food science and technology has been at the core of so many food preparation and packaging technologies that we take for granted. We also talk about how we might be able to use these technologies to address hunger and reduce food wastage. It was an absolute blast talking to Vickie, and I really hope you enjoyed this conversation. Vickie, it is such a treat to talk to you today and learn about your experiences as a food scientist at NASA Space Food Systems for over 3 decades. Thank you for taking the time.
Well, thank you. I'm pleased to be here, and I thank you for inviting me to participate.
I think it makes sense to go back to the beginning of your career at the Space Food Systems and talk about the status of the technology around food, around feeding astronauts when you first began, the needs of astronauts, as you've seen there, the challenges, and some of the solutions you developed. And we can walk down this memory lane to the current day technologies. So let's start at the beginning.
I came to work very early in the shuttle program. I think only 16 of the 135 flights had flown when I came to work there. And I came to work as a contractor. Actually, I was hired to help design the frozen food system that was going to fly on Space Station Freedom. And Space Station Freedom was what the U.S. thought they were going to build. This was before any thought of the International Space Station. I was working for a company called Technology Incorporated, not the TI that invented the first calculators, but a different TI. And they were the prime science contractor at NASA at the time. And they actually still are. The company has changed names multiple times, but they were recently purchased by KBR. So they are KBR, but they're still the same group of people who have been the prime contractors for the Life Sciences Directorate at NASA all along. So I was supporting like I said, food design for Space Station Freedom, and among my duties as assigned was to support Rita Rapp. She was the NASA manager for the Space Shuttle food system. And so I got introduced to the shuttle food system by working for her. And mainly what I was doing was testing the freeze-dried foods that they would produce in the lab. I would run moisture analysis and get them prepared for microanalysis and things like that. And I also supported the food sessions that they did for the astronauts. The shuttle crew members would come in and they would taste the food and then they would select their menus. And so on Shuttle, it was a personal preference menu. So they would look at the list and they would design their meals from the list of available foods. So they would say, breakfast day one, here's what I want. Lunch, dinner. It was exactly what they selected. We called it a 100% personal preference menu because they got to choose exactly what they wanted. Back then, the freeze-dried and thermostabilized, just as they are today, they were a huge component of the shuttle menu, also commercial off the shelf. So even back then, the COTS items were things like the powdered beverages, cookies, crackers, candies. NASA did not do those custom. They just would buy those and package them so that they could be utilized in microgravity. So in the shuttle program, the menu selection, the list of available foods was quite a bit shorter because the shuttle flights were so much shorter than now with space station. They're up there for 6 months and sometimes as long as a year or more. And so when we switched to space station, we had to expand the variety that was available because of the amount of time that the crew members were going to be on orbit. The technology in Shuttle, for instance, we flew the MRE entrees, the meals ready to eat. So we would buy the thermostabilized entrees from the MREs, the pouched entrees. So whatever the contractors were making for the military, that's what we had available on our menu for the astronauts, the entree items. And that was fine for Shuttle. But then when we went into the space station era, we had the MRE's entrees are very high in salt and fat. And the military has good reasons for having the salt and the fat, but they're a negative for crew members in microgravity. So one of the big changes NASA has had to make over the course of the space station era is to start doing their own custom thermostabilized pouched items so that they have lower salt content, particularly because a high salt diet in microgravity is a big problem for long duration because it can exacerbate bone loss in microgravity. We had to switch from using those high salt MREs. NASA had to start making their own. And originally for Space Station Freedom, which when I was hired to work on that, we thought we were going to have a freezer. So Space Station Freedom was going to have frozen food, and it was going to be the first time, the only food system NASA's ever flown that had frozen food was Skylab. So Skylab was actually the most sophisticated system food-wise that NASA has ever flown because it did include frozen food. But when we left Skylab and went into the Shuttle era, it was back to all shelf stable. Shuttle was designed really to be a work vehicle. So there was never a thought of having something as sophisticated as freezer on board, not for food. Space Station Freedom, and then later when Freedom morphed into ISS because NASA quickly over the several years realized they were never going to have the funding to build a space station on their own, nor were they going to be able to do it in a timely manner, even if they got the funding. Then the whole concept of partnering with all these other countries, first the Russians, to develop the International Space Station. The original concept for the International Space Station was we were going to continue that frozen food system. There was going to be a U.S. habitation module that was going to include freezers and refrigerators for food. And so this was in the early 90s when we were talking about this. Probably about 94, 95, somewhere along in there, the engineers started studying how much power they were going to get from the solar arrays, because the solar arrays were going to be the source of electricity on ISS. And when they looked at it closely, they quickly figured out, and they told the space station program, you can either have freezers for science or you can have freezers for food. Of course, science won out, and we were back to an all shelf stable food system. And so at that point was when the gentleman, Dr. Charles Borland, who was managing the ISS food system at the time, he went to the program and he said, look, you have all this money in there for us to develop this frozen food system. Leave it in there. Let us develop our own thermostabilized entrees so that we can no longer have to depend on those high salt, high fat MREs. So mid-90s was the point where we really started developing new products, at least during my career. First time we had really developed new products, and it was thermostabilized items to replace those high salt, high fat MREs.
This is a fascinating story so far. There are so many threads I want to go down. Let's start with the first thing about how long were the shuttle's astronauts gone for in the beginning? Now they're going for 6 months to a year now. How long did you have to plan those trips?
On Shuttle, early on, the very early flights were very short, like a couple of days, when they were still proving the vehicle. After 16 flights, after I got there, the flights were typically about a week long. And then over time, they expanded. And by the end of the program, they averaged right around 2 weeks. Roughly as long as they got was about 2 weeks. And early on, the very first shuttle flights only had a couple of crew members. Then they expanded and eventually got to 7. And there was even a flight with 8 at one point, but it was really set up to support a maximum of 7.
So it's relatively speaking easier to plan a trip with food for 7 days. For a week to 2 weeks, it's relatively easy, and they pick their choices and off-the-shelf foods and some frozen foods. It's easier. I think frozen food was still going on the shuttles, so it was...
No frozen food.
On the shuttles either? Okay.
It was all shelf stable, yeah.
Okay.
Because there was no freezer for food on the shuttle. When they first started Space Station, the first dining module that they had on Space Station was actually the Russian service module. When we partnered with Russia, one of the things that they provided was they provided a service module, which was a duplicate of the one that they had for their Mir space station. So they basically just recreated the module that they had before. And so that was where all the dining was located initially on Space Station. And there were no freezers, no refrigerators. It was all shelf stable. In fact, they didn't even have chilled water. And they still don't have chilled water on the ISS. But they had no chilled water. And so all the dining was done at the table in the Russian service module. And so as station got bigger over the years, at one point when they went to a crew of 6 versus 3, they added a second food preparation area over in the U.S. side of the station. And so at that point, in that new galley, they included a small chiller, really small, about the size of a typical home microwave, but it at least enabled them to prepare a beverage using ambient water and then chill it so that they could have a chilled beverage for after they exercised or whatever. When they added that second food preparation area, that was the first time they actually had a means to have a chilled beverage.
A chilled beverage
on board.
Wow.
Yeah.
We take things for granted here on Earth. You mentioned something about thermostabilized food. What is thermostabilizing?
Thermostabilized is canned, basically, canned food, except NASA does it in pouches rather than cans. So the pouched, just like the MRE entrees, the pouch that the MRE uses, it was developed years ago in a research project between academia and industry and the military. The military was very much interested in getting away from the cans because the cans are so heavy. And so all of the rations used to be in cans, but they wanted to get away from that because the pouches save so much weight. And when they're shipping food around the world, that's significant. The military was the one to come up with a pouch. This research project came up with a pouch that could be used in the retort instead of a can. And so thermostabilized food is basically food that has been put through a retort, and the retort is a piece of equipment. This is canning. I mean, canning is a very old process. It's been around for a long, long time. But basically, you seal the food in a can or a pouch, and then the retort uses a combination of heat and pressure to kill all of the bacteria that's inside the container. What you end up with is a product that is considered commercially sterile. And so that's what all your canned products that you buy in the store, they've been through a retort process. And so that's what the MREs had been through. That's what NASA uses for their thermostabilized foods. They make them all in pouches.
So it looks like NASA was dependent on the US Army, the military, for their food needs. And they developed the technology with academia and industry, and they came up with the pouches and retorting.
I would say they were depending on the military for the thermostabilized products. But all along, NASA was doing freeze-dried food in their food lab. And so they've been producing custom freeze-dried foods. Even when I first came to work there, they were making freeze-dried products. They just weren't making thermostabilized products.
How happy were the astronauts to eat this freeze-dried food? And
Well, most of the comments I got was, it's not gourmet, but we got really pretty good feedback on the food. Given the circumstances, they thought it was a pretty good menu. So I told you on Shuttle, they could select their menu. Depending on the length of the mission, we would have some crew members that would come in and tell us if their mission was 10 days long, they would give us 10 different menus, breakfast, lunch, dinner, snack, whatever. Then we had other crew members who would say, I'm going to give you 3 days and you just repeat it for however long you need. We had one interesting crew member. This is the only time I encountered this. He would choose one day and he would repeat it for however long the flight was.
oh, Lord.
And he liked our shrimp cocktail. So on that one day, he had shrimp cocktail at breakfast, at lunch, and at dinner.
Oh, geez.
Of course, he had other stuff at breakfast, lunch, and dinner, but he made sure that shrimp cocktail was included.
Oh, boy. This is fascinating. I can only imagine what the problems could be for a 6-month-long flight. But before we get into those issues, what is the taste like and the texture like? Is there any change that happens over a period of time? Does it get cooked in the retort?
Oh, yes. The amount of heat that is applied, yes, it is cooked. In fact, in many cases, the product, the recipe, the formulation is prepared and cooked ahead of time. And all the retort is doing is killing the bacteria. In many cases, it's already a cooked product that you're sealing inside the pouch or inside the can. And then you're using the heat and pressure of the retort to make it commercially sterile.
Thank you for that clarification. I'd like to touch upon the testing process that you use in this. How do you make sure the food is still safe and tasty? And then does it change in the texture or the taste or the nutritional value over a period of time?
And the answer is yes, it does. And then I can actually talk about some of the challenges that
Yes,
come
please.
with a Mars mission because of what you're talking about. So even though by freeze drying or thermostabilizing, you have basically inactivated the bacteria. You've killed them. In the case of thermostabilized, you made it pretty much commercially sterile. In the case of the freeze dried, by removing the water, the amount of moisture that's available, you get it so low that the bacteria can't grow. We would test for pathogens. So like with the freeze dried, we had a list of pathogens that we would test for. So we would make sure no salmonella, no E. coli, those kind of things. So we would test for all the bad bacteria. But in the case of the freeze dried, there was still spoilage bacteria in there. It just could not grow because there was no moisture available. But as soon as the crew members added back moisture on orbit, then the food could spoil. I talk about this in my book too, but there was one instance in particular, and the crew members, because the thermostabilized were sterile, they kind of got in their mind, some of them did, that maybe the whole food system was sterile, but it's really not. So when they would add water back to those freeze dried, they would have to either eat it or trash it because it would spoil, and they had no refrigerator for leftovers. So it was either eat it or get rid of it. One time in particular on Shuttle, they would often stow all the meals together. Everybody's breakfast for a particular day would be together, and they would have color dots on the package according to whether it was the commander, the pilot, so that they knew whose food was who. And whoever was least busy at mealtime, they would go down and maybe prepare food for everybody. So in this particular instance, an orange juice had been rehydrated in a package and it never got consumed. And so they put it back in the tray. And over the length of the mission, it grew enough bacteria, produced enough gas that it blew up that package. And so there was sticky, spoiled orange juice all over that tray. Well, the crew member never had to get back in there. That was from day one or day two. They had moved on, so they never had to open that tray again. But boy, when the shuttle landed, I really got the complaints from the people who had to deal with that mess in that tray when they went to clean that out. So the crew members, in their mind, they didn't really think about the fact that this thing would blow up, but it did. It spoiled and it blew up. But even though you inhibit bacterial growth through the way you treat the food, you cannot stop the chemical changes that occur in the food. Over time, what's going to happen is the things like the flavor, the color, the texture are going to change over time. Not in a good way, not like fine wine getting better with age. And certain nutrients, not all, but certain nutrients will degrade because of those chemical changes as well. So that is the huge challenge that NASA has for a food system for a Mars mission. Because going to Mars, the exact scenario for a mission to Mars is still up in the air. But in looking at the current propulsion technologies and the way you have to wait for Earth and Mars to align before you can launch again, chances are that the food that the crew eats on that return flight from Mars, because once they get to Mars, they're going to have to stay there quite a while before they can even attempt to come home, somewhere in the neighborhood of 18 to maybe 27 months before the alignments get exactly right. So what that means is that the food that the crew eats on that return mission could be up to 5 years old and maybe older, depending on if they decide to pre-position the food before the crew gets there. There's a lot of factors that play into it, but the food they eat on that return trip is going to be really old. NASA wants the crew to be high performing even on that return flight from Mars. So the challenge is how to have food for them that's still, from a microbiological perspective, we can do that. We can produce food that will be safe to eat after 5 years, no problem. But the challenge is, will the flavor be good? Will the texture be good? Will the nutritional content be adequate? That's the challenge, how to deal with those chemical changes. That's what's difficult to deal with in the shelf life of the food, is how to slow down those chemical changes. Because the military's done a lot of studies with MREs out in the field. And what they find is if the quality is not high enough, and if there is not enough variety, that over time the soldiers will tend to eat enough to survive, but not really enough to thrive. And so NASA, like I said, they want a thriving, high-performing crew throughout a Mars mission. So that's a big challenge for the food system, is how to deal with the shelf life of the food.
Let's talk about the challenges here. But before we move in there, what is the longest the food has been tested for at NASA or the military that has been okay for somebody to consume?
That's a hard thing to answer, because in shelf life testing, you can do something called accelerated shelf life testing. And this is something that the military came up with. And so what you do is you store the food at a higher temperature, because what that does is it accelerates those chemical changes. By looking at the results of that, you can speculate as to how long the food is going to have good color, good flavor. Right now, what NASA needs for space station is about a 2-year shelf life. But with space station, they can resupply. It's not a problem. For that first Mars mission, you're not going to be able to resupply. More than likely, they may have to pre-position a lot of the supplies, not just food, but a lot of the supplies, because for a crew of 4, which is what they're talking about, and for the length of mission that it's going to be, probably around 3 years-ish, that's a lot of food, that's a lot of supplies. It's likely they might not be able to take it all with them, so they'll have to pre-position, which means that's going to make the food that they eat on the return trip even older. For NASA, I mean, right now they're doing shelf life studies to see what they can do to try to extend the shelf life. But the thing is, the commercial food industry, they don't need that kind of shelf life. They don't want you to keep stuff for 2 or 3 years. They want you to go out and buy new. So people like the military and NASA, and if you look at people like certain religious faiths who store food, those are the people who have an interest in extended shelf lives. Really, the typical commercial food industry doesn't have an interest in making food that would last that long.
We'll come back to the commercial food industry a little later. But first, I want to touch upon, maybe we should talk about the menu. Are there categories of food that last a little longer than the others when you pick the menu items?
When you do thermostabilized or you do freeze-dried, it's not so much that one kind is going to last longer than another. It's more like some products, it's more possible to freeze-dry some items than it is other items. It's more possible to thermostabilize some items than it is other items. And some products are very, very difficult, if not impossible, to make in a shelf-stable form. So it does limit or exclude certain products just because there's not a good way to make them shelf-stable and give them a long shelf life. Take lettuce, for instance. I mean, what can you do to lettuce? You really can't. So that's why NASA's looking at things like they have the veggie unit on the ISS where they
Grow them there.
They grow pick and eat crops like lettuce and cherry tomatoes and things like that. And they're looking at that research because they really figure that they're going to possibly need something like that for a mission to Mars to be able to provide some type of pick and eat stuff that really you can't come up with a shelf stable version of those things.
Was there ever a case where somebody got sick eating the food?
Not that we knew about. I'm sure it probably did happen, but a lot of that was considered private medical data.
Uh,
And I think a lot of the astronauts would really not want to share if they had a foodborne illness on orbit.
That's a hard one, I guess.
I don't think that would be something they would want everybody to know. But I can not say that it never happened, but I can say it obviously did not happen very often, or we would have heard about it.
Exactly. They would have stopped the process. What I'm trying to get at is, I think the technology is safe enough. And then what we need to work on is elongating that process to about 5 years.
Yes.
So the food is stable. I want to shift gears and talk about something about preloading, whether it's a Mars mission or the ISS or any of these things. I think you mentioned very briefly in our first conversation about the European Space Agency sending shuttles loaded with food and issues with sending food through that process.
So basically, on the ISS, the way the food system is currently divided up, the cosmonauts are fed by Russia. So they have a company, a dedicated company in Russia that makes food for the cosmonauts. So they provide all the food for the cosmonauts, and the NASA side is providing food for everybody else. So the European ESA astronauts, the Japanese JAXA astronauts, the Canadian astronauts, when those folks fly, NASA's providing their food. Now, what NASA does allow is their country can send a certain amount of food for their crew member. And as long as it meets the shelf life requirement and the microbiological requirement, it can be stowed in the preference containers for the ISS crew members. When we started out with ISS, so you're talking about 2000, early on ISS, we tried to stick with the personal preference menu, where we would let them select what they wanted. And the problem was the first increments on station were around 4.5 to maybe 6 months on station. And so we would let them select the food, and we would package it up, put their name on it, and ship it to orbit. But the problem was the crew member and the food were never on the same vehicle. The crew went up either in the shuttle or on the Soyuz or whatever to station, and those vehicles didn't really have room for a tremendous amount of cargo. We had cargo flights that were unmanned that would take up cargo. A lot of the food went on those unmanned cargo flights. Unfortunately, what would happen is the cargo flights would slip. Things would happen. Technical problems with the rocket that was launching the cargo, or weather problems. So they would get delayed. And what would happen is that crew member would not get all of their food while they were up there. They would get some of it, but not all of it. So they would come back and they would complain we always had debriefs with the crew members afterwards. So there would be a food debrief where they would give us feedback, and they would complain loud and long. They were like, you promised me I was going to get the food I selected. And part of the time I was up there, I had to eat Joe Blow's food, and Joe Blow had terrible taste in food. So it was a big psychological issue. And when ATV came along, the automated transfer vehicle, that was ESA's cargo vehicle. And so they were going to produce a series of 5 ATVs that were going to be an unmanned cargo vehicle to take cargo to the station. Well, when the first one was going to fly, NASA wanted to load it up with food and with clothing, because at that point it was a new vehicle. They weren't confident it was going to make it. They didn't want to have a bunch of one-off science equipment or anything like that on that vehicle. They wanted to put a lot of food on there. And the flight kept slipping because it was a new vehicle. And it's like, well, the first launch has been delayed. It has been delayed. It has been delayed. And so we had no idea who was going to be on board when ATV got there. And so we talked to the lab and we said, look, let's just come up with a standard menu, and you make this menu and use as much variety, as little repetition from our food list as we can. And let's put that on ATV. That way, no matter who's there when it arrives, they'll be able to find something they like because we'll have big variety. So we went to the astronaut office and said, this is what we want to put on ATV. And so left it for their consideration. And much to my surprise, the astronaut office came back and said, not only do we want you to use this on ATV, we want you to use this from now on, because it got rid of that complaint that I had to eat somebody else's food. So beginning with increment 16, we implemented the standard menu. And I believe they're on increment 69 right now. So the standard menu has been in place all this time. Now it has been tweaked along the way because some of the commercial products went away, or NASA made some new products and they wanted to put that into the standard menu. So there's approximately 100 different foods and beverages that are part of that standard menu now. So it's pretty big variety. And it's packed per what we call pantry style. So all the meats are packed together, all the veggies are packed together. So even though it's a standard menu, the crew members are not eating it per the menu. So it's packed into 8 different categories. They have one of those categories open all the time. So when they go to eat, they're just going to go to those containers that are open. They're going to pull out what they want for that meal. So they do get some preference. It's not like they're being told you have to eat this at this meal. They just choose from what's available. But as part of the astronaut office agreeing to use the standard menu, they also negotiated for some preference containers. If a crew member's on orbit for 6 months on ISS, they're going to get a total of 15 preference containers. 9 of those are going to be food type items, and 5 of those are going to be beverage type items. So for the beverage type items, mainly those were put in place for the coffee and the tea drinkers, because on orbit, all they can do is add hot water. You'd have to tell us, do you want black coffee? Do you want creamer, powdered creamer in your coffee? Do you want artificial sweetener or sugar? So that would have to be prepared ahead of time. So that was custom to what the crew member ordered. That would go in the beverage preference containers. And if they weren't coffee or tea drinkers, then they could choose other beverages from the menu to put in their preference containers. On the food side, this is where the international food came in. So if the crew member was from Europe or from Japan or Canada, their country could send stuff that would get packed in those preference containers for them. Then what you had a total of about 15 containers that you had to get there at a certain time. And that was much more doable because the total 6-month supply would be more like 70 containers. The smaller number was much easier to manage, much more successful to get it there on time. So now it is a combination of a standard menu augmented with a small number of preference containers.
Thank you for filling that information. Fascinating. How ethnically diverse is the food that NASA prepares?
I would say not very much.
Is it because it is hard to make the other foods, or is it preference that the American astronauts are?
Part of it is preference, I will admit. And part of it is a legacy from Shuttle, because a lot of the foods that we did, not all, but a fair number of the foods that we did on Shuttle have carried over to station. Especially early on, there wasn't a big international necessarily component to Shuttle. But I think part of the problem is just having The food scientists who work in the lab to develop products don't necessarily have the familiarity with all these other cultural foods to be able to produce them. They don't have that familiarity.
Looks like this is an opportunity for others to work with NASA and to facilitate that diversity. And I'm sure astronauts would love to eat some other forms of food.
When countries send preference food, they enjoy that and they share it. Even though the cosmonauts supposedly only get Russian food, that's not what happens. They trade food all the time on orbit. Definitely, they trade food.
That is good to know that they get some diversity there. Let's talk about the infrastructure needed to prepare this food. Talk about the labs that you have, the facilities, and the challenges there.
So the biggest challenge, other than the shelf-stable whole issue, but the biggest challenge in food preparation is how to deal with liquid in microgravity, because everything's going to float. And so on the beverage side, the package for the freeze-dried food and the package for the beverages has a custom adapter in the top of the package. And inside the adapter is a septum. And the septum is a little plastic valve that has a slit in it. They use a needle from the galley and insert it into that slit. And then they inject water into the package. And so on the galley, they can dial up the quantity of water and it will automatically inject. On station, it's either hot water or ambient water, room temperature water. Those are the two choices. So it will inject the water through the needle. And once the needle is withdrawn, that slit closes off to prevent the fluid from flowing out of the package. In the case of the beverage, in order to drink, they're going to have to insert a straw into that septum. And the straw has a very stiff, rigid tip on it that holds open the septum so that the fluid, the beverage can flow back up the straw. But then they have to have a clamp on the straw so that in between sips, they clamp it closed. Otherwise, it would slowly flow out of the package. It would form a big ball on the end of the straw and eventually get knocked off and make a big mess. On the food side, when foods are prepared, the viscosity or the thickness of the food has to be taken into account. When we prepare the soups that NASA flies, NASA has, for instance, a split pea soup. Well, it's very thick. It's probably thicker than the typical split pea soup would be down here. And that's to make it more manageable in microgravity. Because when you cut that pouch open to eat, you want it to either stick to the package or stick to your utensil, to your spoon or your fork or whatever. And so viscosity is an important part of planning. For instance, there is a chicken consomme as part of the menu, but it has to be drunk through a straw because it's thin. It would just make a huge mess if you tried to open that. It's typical consomme. It's very thin, and so it has to be drunk through a straw.
And I'm assuming that your facilities have a zero gravity room where you test out all these things before you go there?
No.
Whoa. Okay.
No. No. So I will say that during my career, we redesigned the package for the freeze-dried food and for the beverage. So the original package that was on the shuttle was a very rigid square package, very hard plastic that had a plastic lid sealed on the top of it. It was like a bowl. And so those packages were designed to nest inside each other and in stacks. And so that's how we would send them to orbit. They would be stowed in the mid-deck locker trays in stacks. And when the crew members put them in the trash on the shuttle, they were supposed to stack them as well. They never did. For the most part, they just got chunked into the trash bag. And of course, on shuttle, all the trash came home. They didn't jettison anything overboard or anything. It all came home. When the Challenger accident happened, And we were down during that time, not flying the shuttle after Challenger. We were tasked with redesigning the package. They wanted something less rigid that would take up less room in the trash. We had a packaging engineer in the lab. We started working on redesign. And at that time, we did use the KC-135 that was at Ellington to do parabolic flights over the Gulf of Mexico. And so on these parabolic flights, you would go out over the Gulf and you would climb up, and literally you were doing parabolas, up, down, up, down. And at the top of the parabola, you would get a very short period of weightlessness. And that's how we were able to test the packages.
Wow. I assumed that some of the astronauts have a zero gravity facility where they're trained on the ground. And so you get to use similar facilities for preparing and checking out the food.
So the closest the astronauts can come to zero gravity is in the pool. When they're training them for EVAs, they put them underwater in the pool because that's the closest they can come to simulating what it's going to be like for them in space on the EVAs.
Wow, I learned a new thing today. So much for assuming things there.
NASA would love it, I'm sure, if somebody could come up with a zero gravity chamber so that they could do that on the ground.
That should be a hard physics problem to solve.
Yeah.
Moving along, one other topic I had in my mind was, does NASA collaborate with industry or academia in developing any of these food technologies?
It's complicated. So NASA puts out a lot of calls for research to academia. They'll fund grants. So over the course of my career, there were various universities that had research projects funded by NASA, but they weren't necessarily directly working with us, the folks in the food lab. The research that NASA does in the food lab is very much applied research. So it's not your basic research like university people do or like graduate students do, for instance. And so that's why NASA had a whole separate mechanism for funding the more basic research, because what we were doing in the lab was focused on what we needed for missions.
Do you have an example of what that basic research project would look like that you funded, and an applied research project, if you have some stories?
So one of the projects that got funded while I was there, and I mean, there were a bunch, they had what's called SBIRs. You know about SBIRs?
Yes, we do.
Okay. NASA, just like just about every other government agency, have SBIRs. For instance, during my career, they funded SBIRs related to growing cell culturing of meat, cell culturing of fish, 3D printing of food. Those were the kind of basic research things that would get funded. We didn't have money for that kind of research in the food lab itself. One research project that we did internally during my career, when I first came to work on the shuttle, they were flying sliced bread for the crew members to make sandwiches. Literally, they'd go to the store, get a loaf of bread, transfer it to something like a Ziploc bag, and send it to orbit. And then we had a payload specialist from Mexico fly, Rudolfo Neri, and he wanted to take tortillas. And this was shortly after I came to work there. He wanted to take tortillas. And at that time, a lot of the astronauts weren't necessarily that familiar with tortillas, but they saw how he could take a tortilla, slap something in it, roll it up. It was like having a sandwich without having to deal with two pieces of bread in microgravity and all the crumbs that the bread created. And so they're like, forget bread. We want tortillas. Of course, being the good Anglos that most of them were, they didn't want the corn tortillas that he took. They wanted flour. So from then on, we would put flour tortillas on the flights. At that time, there really wasn't a lot of tortilla production facilities in the neighborhood of Kennedy Space Center, but there were tons in Houston. And so what we did was we went around Houston, got samples from a bunch of different tortilla manufacturers. We chose the one that had the lowest yeast and mold count. And that's where we bought our tortillas, because yeast and mold is what makes them go bad. And so low count, longer shelf life. And so we would buy them. We would typically go to the manufacturer the morning that the crew was going to leave for Florida. The NASA plane would fly them down to Florida. We would send somebody to get tortillas hot off the press, put them on the plane, and that's what flew on the shuttle for them. And that worked well when the shuttle flights were, say, 10 to 12 days long. But then when they got longer, we needed a tortilla that was going to last even longer. And so we did a research project in the lab to develop a extended shelf life tortilla. The military had quite a few extended shelf life breads that they used for the MREs. And those were packaged in a pouch, and they were packaged anaerobically to remove 100% of the oxygen. So by removing 100% of the oxygen, no yeast, no mold, can't grow, no oxygen. But in doing that, you can't just take any old piece of bread and package it anaerobically, because the water content would be high enough that anaerobic pathogens could grow. Clostridium botulinum was one of them. There's some pretty nasty anaerobic pathogens. So what the military did was formulate the dough with binders to bind free water. Because if you get the free water below a certain level, no bacteria can grow. And so that's how the military did their ESL breads. We knew that's how it worked. And so we formulated our own low water activity tortilla. And so for a few years in the food lab, we were in the tortilla manufacturing business. We had the dough divider, the dough press, the whole bit. We were making them, packaging them, putting in an oxygen scavenger in the package to make sure all the oxygen was absorbed. And those would get about a 4-month shelf life. And then they would develop a bit of a bitter aftertaste. But a 4-month shelf life, that was more than we needed for Shuttle. But when we were going to go into the space station era, we knew that we're going to need more than 4 months. And so we were about to start another R&D project in the lab to research, why were we getting that bitter flavor? How do we get rid of that so that we can get an even longer shelf life? Well, about that time, a company, and I think it was Taco Bell, but I'm not 100% sure on that, but they came out with a soft taco kit, and it included the tortillas. And that kit had a 9-month shelf life. Well, we're like, that has got to be a low water activity tortilla. So sure enough, we got samples, tested it. It was low water activity. So we found out who was making that tortilla, and we started buying those and packaging them. And so we were able to get out of the tortilla production business. All we had to do was package them. And then several years later, all of a sudden, the military had an extended shelf life tortilla, just like their other extended shelf life breads. They had never had that before, but they came out with one. And so we wanted to get samples of it because we were buying some of the other extended shelf life breads from them to fly. We said, man, let's sample it and see if it's good. If it is, we don't even have to package them anymore. We can just buy them already packaged. So we got samples. We did a blind taste test in the lab. Some people said, I like ours better. Some people said, I like theirs better. And then others said, I can't really tell a difference. Well, when we researched it, we found out the military wasn't making them either. They were buying them from the same people we were buying them from.
That's a funny story. Looks like there's been a lot of collaboration between the military and the NASA. Is it an ongoing thing or
Yes.
does it go on and off?
Natick Labs in Natick, Massachusetts is the R&D facility for the military. And so over the years, especially early in my career, there was a lot of back and forth between Natick and the NASA Food Lab. For instance, when Natick had new MREs that they had developed, they would send us samples so that we could try them. And if we liked them and they became part of the regular MRE menu, then we could buy them. So that would kind of give us a heads up on what was coming down the line in the MREs. They would come up with new products, and then as they changed the MRE menu, they would incorporate them. We did a lot of that. And actually, when we started developing thermostabilized products, we would let them try ours. And I distinctly remember that one of the desserts that we did, they liked it so much that they did their own version of it.
Of course.
There was always a fair amount of collaboration. It was even more so in the early space program before I was part of NASA. Before I worked there, you go back to Mercury, Gemini, Apollo, there was even more collaboration between Natick and NASA.
That's interesting. Before I forget, you mentioned something early on that if there's any microbes growing in the packet, it's going to release carbon dioxide and it explode.
It can. It depends on the particular bacteria that's growing. But there's quite a few bacteria that can produce gas. So it depends on what particular bacteria. But in the case of that orange juice, there was a gas producer in there that blew it up. Yeah.
The reason I'm trying to bring that up is I think it's a clear sign for them not to eat if they see a bulged package.
Oh, yeah. Just like at home, if you have a can, it's got the puffy lid. Yeah, you better not eat that. If you got a can in your pantry that's got a bulging can or a puffy lid, yeah, you need to put that in the trash.
I think what I was trying to also allude is the elephant in the room. Everybody wants to eat fresh food. Old food is not seen very kindly. Now we are talking about trying to stabilize the food for 4 to 5 years. I'm trying to understand the psychology of the astronauts who are going to be eating this food. What do they go through and what parts do they accept? And I'm just trying to, if you have any insights about their psychology.
On Shuttle, many of them would say to me, this is like a camping trip. It's short. It's no big deal. I don't care. I'll pick something. I'll be fine. In the early 90s, when we were going to send our crew members to stay on the Mir space station as part of the preliminary to building the International Space Station, NASA sent crew members to stay on the Mir space station. And those first crew members, the original plan was that there was going to be no NASA food on board the Mir when they went to stay there. And NASA went through some negotiations to at least get a small amount of NASA food on Mir so that they weren't just eating the Russian food, because at that point, our crew members had little to no familiarity at all with the Russian food system. I can remember going to some of those first crew members who were going to be on Mir and saying, what do you want to send? We only get to send a small amount of food for you. What would you like us to send? And I can remember from one crew member in particular hearing, look, I'm too busy learning Russian and training for the Mir. So just go look at one of my previous shuttle menus and pick something out. It'll be fine. If I selected it for Shuttle, then that meant that I liked it. So that's what we did. We went and picked from their previous menu, because these were all crew members who had flown on Shuttle before they went to Mir. But I can remember some of those crew members coming back and saying, I should have paid more attention to what you sent, because they were there for, on Mir, I think the typical stay was about 4.5 months, something like that. So that was a tremendous increase from a 2-week shuttle flight. And so once crew members were staying long duration, then the importance of food changed quite a bit. The psychology of food really started to play into it because the crew members were there for such a long time.
Makes sense.
And it's going to be even more difficult for something like a Mars mission because it's going to be another power of magnitude longer than a stay on ISS.
Do you happen to know which space systems in the world have the most advanced food technologies, if it does exist?
The Russians pretty much do what we do. They have freeze-dried, they have thermostabilized. And to be honest, I don't have a lot of insight into what China's doing. I really don't know what they're doing.
Yeah, they have much longer missions.
Yeah, I really don't know what they're doing. But all the other space programs, right now, NASA and Russia are the only ones who have established food systems for space. When ESA wants to provide something for one of their crew members, they're going out to a commercial food company in Europe and having it made. ESA doesn't actually have a food lab where they're making stuff like NASA does, and like Russia has their dedicated facility that makes space food for the cosmonauts. ESA doesn't have that. JAXA doesn't have that. Canada doesn't have that. So they're basically either going out and identifying commercial off-the-shelf products to send for their crew members, or they're having something special custom made by a food company to send. But they don't have dedicated food labs like NASA does.
I'll try to research that. It's of personal interest to me. Maybe it's a good time to change the gears and talk about using these technologies to address poverty. What you guys are achieving here is much longer shelf life. We hear about food wastage all over the world, whether it is fresh produce or any of the foods that you talk about. And then there's just about 250 million people starving in this world, whether it is Africa or war-torn areas. My heart is there. I think as the population is growing and with the weather changes and everything else, I think we should be able to better use the resources that we have while being able to feed poor. I just want to hear your thoughts on that and exporting this technology to feed other people. There's an effort going on.
The technology is there to do it, to be able to send pretty long shelf life food around the world. It's an economic thing. The cost of doing it is a huge component of it. Also, it can be politics. I mean, there's certain countries that aren't going to let you bring food in. There's definitely politics involved as well, but a huge part of it is money.
I never brought up this question, I guess. You bring up money, like how expensive is this whole process? How much does it cost for each astronaut in terms of food?
Well, in fact, I just had a student email that question to me. What does it cost to do food? And to look at space food, I mean, if you look at the cost of MREs, I mean, the military could give you that. In fact, you can go out online and you can buy MREs.
Yeah, I saw it on Amazon.
You could do that. But the thing about space food is the thing that makes it more expensive is not so much the food itself, it's the special packaging that has to be done, like the septums, and that's very expensive. And when you talk about what does it cost, it's like, okay, well, what all cost do you include? Do you include the cost of preparing the item? Well, yeah. Cost of packaging it? Yeah, that could be included. What about the cost of packing it, shipping it to the launch site? What about the cost of the person who stows it on the vehicle? But the real cost of space food is the cost of launching it. And the cost of launching it negates all the other costs because that's what's so expensive is getting it to orbit.
I think that's a very broad question. Like I was looking up something online and they mentioned about $2,000 per day per astronaut. I assume the bigger part was the commute of moving the food back and forth. My interest in this is I think we as a world have globalized, moved workers and everything else, but we have not been able to move the original food. The best Italian food still is in Italy. The best Indian food is still in India. The best Chinese food is still in China. If we can use these technologies to move this food around, imagine opening a packet of like Chinese food or Indian food and like it's as fresh as possible, has long shelf life because of immigration. People are moving around the world. I think there are many more implications that we can address. It's the use of this technology that I'm very interested in.
In looking at the culinary aspect of food versus the food science aspect of food. A lot of people don't even know what food scientists do. Food science is the reason you can walk in a grocery store and have thousands of products available to you. The processing, the packaging, whatever. But culinary is very different because a chef, when they make something, you talk about great food in China, great food in Italy, it's very hard to process something and have it taste exactly like it would if it came out of an Italian chef's hand to your plate.
Indeed, Vickie, nothing is going to be as good as fresh food from the hands of a great chef to the plate. Thank you so much. You've been very generous with your time, Vickie. Are there topics that we haven't covered that people should know? I think people don't really care about the food science because they're hungry, they eat the food, they don't pay much attention to even how food is grown. Culinary skills, I think TV shows and others have made it glamorous enough that people take interest in that. That is one of the reasons I wanted to bring you on the show, but talk about the food science that goes on. And I just want to salute all these astronauts and people in the military. They're just taking one for us, eating not as tasty food and high in fat and salt and so on. Thanks to them and thanks to you and all the food scientists for making this happen. I just wanted to see if there is any topic that you want to talk about that we haven't covered so far.
I did want to mention that I have written a book about my career, and it's going to be out this coming fall. I'm publishing with Ballast Books, and it's ballastbooks.com. The name of the book is Space Bites, Reflections of a NASA Food Scientist. It's available for pre-order now. I had several motives for writing this book, but one of my motives was to make people more, especially students, more aware of food science as a career, because there's a lot of demand out there in the food industry with food companies of all sizes for food scientists. Those are good paying jobs that a lot of kids going into college aren't even aware of that as a career path. And so that's one reason I wanted to write the book. Another reason is any profits that I make from this are going to go to charity, primarily to scholarships for food science students. So that's my plan.
Congratulations on the book. We will have a link to your book on our show notes, and that is very generous of you to offer all the proceedings to the charity. That is very kind of you.
I hope to stimulate some students' interest in food science as a career.
This is fascinating. I hope I can work with you on this project I'm talking about, bringing the food to the poor and also bring the other ethnic foods to the rest of the world. Globalized, good food. Vickie, thank you so much for your time. I really enjoyed this and lots of learning today. And I hope my audience is going to enjoy this as well.
I hope so too. Thank you.
Thank you for listening to this episode of the Lab to Startup podcast. You can find links to the resources and programs mentioned in these episodes, connect with Naresh, or subscribe to this show at labtostartup.com.